Hey guys, this is your civil bro Mainak, and I'll do today the response spectrum analysis in Etabs so that I don't miss any steps. I'll do it from the beginning. I'll create a basic model and then I'll just perform all the steps and also see the results of the response spectrum analysis as per the Indian code. So first of all, we need to just create a new model here. We'll do the modeling process very quick so that we can just focus on the main part of this video. This is the response spectrum analysis. Okay. So if you want a detailed the modeling part, you can see other videos which are in this Etabs playlist. So we'll just take the 4 and 4 grids in all the directions. Okay, so the uniform grid systems, let's take 3 number of stories. Bottom story height, let's give 1.9, and the 4-story height, let's give 3 meter, and click on OK. So the model will be, so the model is created, you can see like this. So let's define the things which we want to define first. So we'll go to define, and first of all material properties, and in the material properties this one is the concrete, so we'll just modify it. This is the concrete. I'll just do M25, and concrete isotropic density, let's do 25. Okay, so yeah, and then I'll just click on OK. So make sure to click on OK, otherwise it will not be saved. Modify material, this is the rebar property, so FE 550, and this is the rebar property, and we'll just modify the rebar data. You can modify, check all the data. Okay, and click on OK. So these 2 new properties I've added, just click on OK, and then again sometimes it glitches out, so just check whether properties have been added or not. So my properties have been added. Now it's a good practice to save the model, otherwise if there is any error, so I'll limit just save the model in a particular location so that it doesn't stay in the temporary memory, it goes in the permanent memory. Okay, so just click on define, and I'll just define the frame sections, which is next. So concrete column, I know this, just double click or click on modify, whatever you want. Okay, so this is the one, concrete column, sorry, double click on it, and I'll just name this column as C400 to 400. So the aim currently is not designing an economic section. We're just going to give a default section just to show you. M25 has been selected, and this should be selected, and modify rebar, and here FE550 is selected by default. Rebar type is for columns, so it's okay, and the size here 400, and this one is also 400, and click on OK. And once this has been added, concrete beam, I'll just modify this, and I'll just do this for all the beams. B, let's put 300 was 500, and M25 is okay, and this is 300, and modify show rebar. You can see already FE550 has been selected. Click on OK, and then click on OK again, and as again just to check the glitches, just see whether the properties which you have defined have been okay or not. So it has been done. So next definitions which we want to do is the diaphragms. So we'll have 2 number of floats here, so we'll have 2 diaphragms. So modify diaphragm, this is rigid, so then the new diaphragm, add D2, and that is also rigid, and then click on OK. Okay, 2 diaphragms have been added for the 2 floors which we have here, and then we're going to look into the next definition, which is the function response spectrum, but we'll do it later because just response spectrum here as per the IS code. So by default, so the latest IS code is IS 1893/2016, but since I'm using a lower version, so it's not there. So I'll just click on add new function, and function 1, this damping ratio is 0.05, and for the seismic zone 5, as per table number 3, the IS code, the seismic zone factor is 0.036. So I'm using the seismic zone 5 and factor of 0.036 from table number 3. 0.36. And soil type, there are 3 types of soil. You can see here as per table number 1, rock hard soil, medium soft soil, and the description has been given. I'm considering medium soil as soil type 2. So just click on OK. So this has been defined, and I'll just delete this because I did need only one function, and then click on OK. So the next definition which I'm going to do, so I've defined diaphragm, so I've defined the functions, response spectrum, and then I have defined the mass source. So mass source, I'll just modify this. So element self mass, this I think will be better if I just define the mass and then I'll do it. So I'll do it later, so I'm just not doing this right now. So then I'm going to do the load patterns here. I'm just going to add the loads, and then I'll put the mass. So dead and live load are already there. So this cell 1 multiplier means that we are using the self weight here. So apart from the self weight, I'll put the other dead loads in a different category. So other dead, it includes the wall load, it includes the shell, floor finish load, everything. It will be in the other that in the other load. Add new load, and then I'll add the two default SLX. Type will be Seismic, and lateral load is 1893. Add your latest code. I'm adding the latest which I have in this particular version. Okay. You add your latest code and click on add new load, and in the Y direction also add new load. Okay, so this has been added. In just modify lateral load, and in the X just this, and again 0.036 and already explained. Importance factor has not been explained. Come to table number 8 of IS 1893 part 2016 part 1, and you have 3 types of importance factor. Basically, for normal buildings it is 1, for apartments having more than 200 occupancy it is 1.2, and for public buildings like hospitals it is 1.5. so here we are taking this 1 for now. Okay, the importance factor is 1. So and then we have the time period. So time period, program calculated, user defined. So we'll obviously do user defined. So if you look at the clause of 7.6.2, that is the translational natural period T. So this is the bare MRI building. So if there is any building which is bare, which doesn't have any masonry, then we'll use this. But currently, practically, we don't generally have any bare MRI buildings. We have MRI buildings with masonry infill. So this condition doesn't apply. And then you have this one with RC structural walls, where you have RC structural walls. You will use this, but here currently this is we have frame structure, MRF structure, but with masonry infills. So we'll go with all other buildings. So you will this option. So this formula we'll use for calculating. So H is the height. So this is a 2-floor building. So H is 3 into 3 into 2. That is 6. And root D is actually the same here, but it will be different if you consider different things. So you can see root D is both x and y spans are same, so D is same in the x and y direction. So in the x direction D is 16, and in the y direction also D is 16, but generally it will be different in other buildings. So the calculation is simple here, 0.09 into 6 divided by root 16, that is 4. So the calculation comes as 0.135. So I'll use 0.135 seconds in here. Okay, at this base store you can do it at the plinth level, okay, or you can do it as the level of the foundation also. So there is no error in that as per our code. You can do it at the topmost of the foundation level as per our code. So just click on OK here, and same thing we'll do here. Modify lateral load, and user defines 0.135 is the thing, and this one is the y direction. So only y direction will take. I just check this whether I have done it correctly. Yeah, this one is the x direction, that one is the y direction. So it's good. Click on OK. Now this part, having done this part, then we can go to the mass source. So just modify this mass source. No need to change this. Element self mass not needed because we are already considering the dead load. So specified load patterns, dead 1 add, and then the other dead 1 add, and for the the live load will add as per our IS code. So come to table number 10 of the IS code, and it percentage of imposed load to be considered in the calculation of seismic weight. Since we are defining the seismic weight up to this live load of 3, that is 25%. So since this is a residential building, as per the IS 875 part 2, it is 2 kN load, so we will consider 25% of the load. So here it goes as 0.25. So now this is added. Now please don't confuse this seismic load X and Y. This is what we are doing is we are defining the seismic weight. Whether we define it in STAT or whether we define it in Etabs, we do not consider the seismic load, because this is the actual seismic weight, and which takes into consideration the amount of dead load and live load. To make it clearer, let's go and ask the IS code. So what does the IS code say? Seismic weight of floor. It is the sum of the dead load of the floor, appropriate contribution of columns, dead columns, walls, and any other permanent elements from the stories above or below, finishes and services, which means all the dead load, and appropriate amount of specified imposed load. So appropriate amount of specified imposed load means as per table number 10 of the IS code. So that's what we are doing here. And seismic mass, so that's we are considering dead load and live load here. So hope you understood this, and just click on OK. So mass source have been defined. Just click on OK to log all the things here. So we have defined the mass source, and then just go to P delta options. In the P delta options, for the analysis, just make this non-iterative, based on mass. So we want the analysis to be based on mass generally. Okay, so then we go to the model cases. So we'll define the model cases, and it should be, in the eigen or eigen, whatever the pronunciation is. So it should be based on the eigenvalues. So then we will do these things. Okay, so model name is 1, and it should be eigen in most cases, and already we have defined that it should be non-iterative based on mass. We'll define this. If you not, you can also do it from here. Now, interesting number of maximum number of modes. So you can just this can be changed. Maximum number of modes, you can just redefine it as per your wish. So let's go to the clause number of 7.7.5.2 of the IS 1893. It says that number of modes to be used in the analysis for the earthquake shaking along considered direction should be the sum total of the modal masses of should be such that the sum total of the modal masses of these modes is at least 90%. So we take as 12 initially, or you can take as 3 per floor, whatever you want. But in the final result, this condition is not satisfied, then we increase the modes. Okay, so that's how you generally operate it. So you can keep this at 12 to begin with. Okay, and then you just click on OK here and click on OK. So the model mass model cases has been defined, and then you go to the load patterns, which you have already defined here. You have not assigned, but you have defined the load patterns, and now we need to define the response spectrum, load cases, and then the load combination. So go to load cases here. You find that we have the dead load, live load, other dead load, seismic load in the x and y direction, and we'll add new case. Here it will be RSX, which is the short term for response spectrum in x direction. So this will be response spectrum load, and here just go. I can add this quadratic method or in square root method, so it doesn't matter. So just you can use the CQC, so no worries in that. You can just use click on add, and here you can add your load. So you have U1 in this RSX. Okay, and damping is usually kept at constant here 0.05, so no worries in that. Just click on OK. So in other conditions can be different, but I'm talking about the general conditions. So RSX we do, and then in case and RSY. So in the RSY and P delta we already just did the thing, and then we go by response spectrum, and in the response spectrum here we'll just consider add a new function here, and then it will be in the U2. Okay, and then click on OK. So the two response spectrum in x and y direction has been defined, and then click on OK. Now having done that, go to define, and we'll go to the load combinations. Okay, and then we just add defined default load combination for the concrete frame design and convert to editable if we want to see it later. Just click on OK. You can see the load combos which are there, and after that you just click on OK. Okay, to save this combinations, and then we go on define, and we'll define our slab properties we haven't defined. So diaphragms we already have defined, so we'll define the slab properties. So we'll go to define section properties, slab sections, right? And then we have slab 1, just modify this, and this slab 1 M25 grade of concrete, and this will get to 150 mm slabs. So just click on OK and click on OK. So this has been done. So now we go to the plinth level, story 1, and then we just go here, quick draw columns, and when you click on quick draw columns, make sure you select the right property here, which is C 400 into 400, and just make all the columns here. And after that we'll just select this option, quick draw beams, and we'll take the beam here, beam property, which is 400 into 400, so not this one, and this one is the beam 300 into 500. Just add all the beams here, and then we want to put the front view here, and then we want to copy. So just select this, and after selecting this you can just go to view and set 3D view, and elevation 0, aperture 0, and plan let's say 90. Okay, so the front view, this is a typical front view of the 3D view, and escape to just to make sure everything is, we are not clicking on everything. So let's select everything. We have selected the beams, and now we have selected the columns, right? So beams and columns have been selected. Now we can just now play around with the 3D view just to see whether we have selected everything, beams and columns except the supports. The purpose of selecting like this is to select except the supports. So selected, the selection has been done this, and we'll go to edit, and we'll go to our replicate and story, and we want to go to story 2. This is okay. Just to check here, over your mouse over apply, you can see the difference here. Okay, so I'm not going to just copy it for the next floor, because I'm going to provide slab here, and then I'm going to copy it for the next one. So just click on apply and click on OK. So once this is done, I will go to this floor, that is the story 2. We're going to go to story 2, and we're going to apply the slab. So here you see draw floor, and here just slab 1, which we have defined anyway. So just we'll use this option. This is better. This quick draw floor wall plan, and this one we will use slab 1, right? So just you can just click on it. In the ideal structure there will be an opening for the staircase, but now we are not considering that. Okay, so now we can copy this to the next floor. So for that, again just click on the 3D view, and then view and set 3D view, and maybe 90, 0 and 0. Okay, 3D views front view part, and select this entire thing, and also this one. So this has been selected, and we'll just copy it to the next floor. So edit, replicate, story, story 3, overall apply. You're good, apply, and OK. So this is done, and you can see in the 3D view, just use your mouse cursors to rotate a bit, and you can get an idea here. And then if you want to see, you can also see in the extruded view. This we have done here in the extruded view, you can see. So enough with the modeling part. So let's go quickly and assign the loads part. So let's select all the slabs and assign the slab loads first. So first of all, we'll right click, just select here, and then select we'll select the object by object type. We'll select all the floors. Sure, select and close. So floors have been selected, and now we'll go to assign, and we'll just click on shell loads. This will be a uniform load, and so for the other dead load, we'll add the floor finish load 0.5. Okay, always use this add to existing. Okay, it's a good habit. Apply, and then okay, and then we want to select this again. So select, go to previous selection. So all the slabs are selected, and then go assign and assign shell loads uniform, and this time we will assign the live load of 2. Add to existing loads always, and click on apply, and okay. Live load and dead load floor finish, which has been shell load, has been applied. Now we have to apply the load that is the floor load. So you have you can calculate the floor load. We are adding a default floor load of 7 here, but you can calculate the wall load, and then you can add, which I have shown in the previous videos. But let's add this here simply. So just 3D view, I'll use it once again, and I'll go to view and set 3D view, and I always prefer 90 and 0 and 0, and click on OK. And then we'll select all the floors except the slabs or the beams. We'll just select this and select this like this, and when these two are selected, we can just click on assign frame loads and distribute it. So we're going to click on dead load or other dead load, okay, and then just go with load of 7. So it's usually 14 for 3.2 meters. You can calculate this and you can apply it here. So I'm just going to apply 7 here, and click on apply and click on OK. And for the parapet wall, we will do something different here. So this will be the parapet wall. So since we're not considering the staircase here, so go to topmost story, and we'll select the perimeter, this beams. where the parapet wall will be there, and we'll just click on assign frame loads distributed, and go another dead and parapet wall, let's apply 3 and click on apply, click on OK. So this has been done. Parapet wall load has been applied, all the dead loads have been applied, self load it will take automatically, live load has been applied, earthquake load it will take automatically. So this has been done. Now one thing we have missed, that is the support. So we'll just select this and we'll go to the portion where you can assign the supports here. So select all the nodes here, assign, joint, restraints, and click on this fixed icon, click on apply and click on OK. So now you can see it doesn't change. So if you just zoom out and click again, it will change. The type has changed to the fixed support. Okay, so we have assigned the fixed support. So now what you need to do, you need to check the model. So analyze and check model, select all and click on OK. So it will show whether the model is okay or not. So model has been checked, no warning or these are present, so it is okay. Then simply go to analyze and select load cases to run. You can just directly click on run, but this time is necessary that sometimes you can check whether all the load which you have applied are present here or not. So all the loads which we know are present here. Okay, so we can run. Okay, click on run now and the analysis will run. So the analysis is run. It's pretty fast since it is small model. So analysis is run. I just can play around the 3D view a little bit. Okay, this one like this. That's it. So the analysis has run. So now let's see the results of our work. So we'll go to display, and the first thing which you want to check is the response plots, and maximum story displacement is around 35 to what is this? This is 40. It is around 41 or 42. Okay, so it is this, and let's check the maximum story drifts. Okay, so just reset this. Let me just display story response plots. Okay, now it's okay. So let's check the maximum story drifts first. So maximum story drift is 7.2, around let's say 7.5. As per the IS code, clause number 7.11.1.1, the story drift shall not exceed 0.004 times the story height under the action of the design based shear. So the particular story height is 3 meters here. 0.004 into 3 meters is 0.012 meters. That is 0.012 meters. That is 12 mm, right? So let's see what is the thing here. So it is around, it is sorry, it's unitless actually. So this is, but considering in meters, so it is 12 mm, and here we have, I think we have 7.5, so it's okay for the maximum story drift. So you can also see the maximum story displacement. It's 45 around. So you can see this maximum story displacement, and you can see the story shears here. You can see the story stiffness, and so we can see the other things. So let's see the maximum story drifts due to the loads here, and you can see this is for the load case combo model, and you can see this is the model load, and any load combination you can see here, absolute max for the dead load you can see here. So for all the particular loads, selects and SLY. So for the different loads you can see the story drifts here. So you can see, check the results here. So I'll just close this now. Story drifts, and then the next important thing which you need is the model response. So show tables. So just go to display and then click on show tables, and here in the design or the analysis. So just results, and then the frame results, and then not the frame results, the model results. And here you can see model participating mass ratios, okay, participation ratios, fraction ratios, and model periods and frequencies. Let's see all of them. Okay, click on OK. So you see these are the model participating ratio, UX, UI, and then you have the modal participating mass ratios. So you can see the UX and UI, and some UX and some UI. So as you can see, this should be minimum 90%, but this is 1, so for the 12 mode cases, so we're totally fine. So if this was less than 90%, then we need to change it and increase the modal number of modes. So we can easily do that, but we are good now. So that's the check as per the IS code. So this should be at least 90% or 0.9. So we're 1, we are good here. So this is a check. So these are the other things which you can check here. The frequencies and the time periods also you can check. So these are the checks which you can do, and the other things, that is the results which you can go here, and you can have easily. This is the display frame. You can see the for any load combination, or let's go for any default load combination there, and let's see the shear force. So for sharing the shear force, just click on shear 2 and click on apply. Make sure you select this and click on apply. So if you want the values also, just click on the show values here and click on apply. You can see the values of the shear force diagram as well. Okay, so you can see the shear force here like this. If you want the bending moment, so go to moment 3 and click on apply. So this is the bending moment diagram here. Okay, you can see in the elevation view also. So this is the bending moment diagram, this is shear force diagram which you can see here. Click on OK. So and then obviously you can see the foundation reactions, but for the for designing the columns, designing the footings, we usually consider the unfactored load combination. So you have to insert the unfactored load combination and then see the foundation reactions. But anyway, you can see the display support reactions here. What we need is FZ, MX and MY, and you can see the tabulated, or just for any load combinations, unfactored load combination you create, just see and click on apply. Here you can find the load combinations here and the tabulated format here for designing the footing. And you can just click on display also and show tables also for the foundation reaction, just showing you for the reactions here, just reactions here, joint reactions and base reactions, right? And click on OK. So you can find the base reactions and the joint reactions. For all the joints, this is for the base reactions which you want, and you can see the base reactions. And for all the load, you can find this, you can copy this data in Excel, and you can just check the maximum, take the maximum value and design. But it should be for the unfactored load combination, that is everything should be 1 into dead load, live load, like this. So this is the case, this is the basics of the response spectrum analysis, the complete steps I had shown you, so that if anyone watches the video from the beginning, just if anyone searches response spectrum analysis, so that he can he or she can make the model, and then they can assign the loads also. So that's what is the purpose of this video, and I hope you like this video. And if you like, please make sure to hit the like button, it really helps out. So keep learning, and if you have any doubts or any video which you want to request, make sure you just drop a comment and I'll definitely reach out to you. Thank you, bye bye.